engineer, but it's okay. Particularly with what we see with the next one, I think. Okay, so the next one says 52 by F1, which is 18.2, minus 25 by 11.8, and this should give me 650. I get 651.4. Yeah, it's just a bit of rounding error. We're not going to worry about it too much. That one is spot on. Okay, that's part B done. Now let us look at question C. So question C says let K be a real constant. Okay, now real number just means some number on the number line, and define a matrix like this. So this is a matrix that depends on K. This is a tricky enough question, to be honest with you, but it tests a few different things. Okay. So it gives us this matrix, says K is a real number. Show carefully that this is invertible. What? Now, I'm not asking you to find the inverse. You will not be asked to find the inverse of any 3 by 3 matrix. But we have a little theorem which says that A is invertible, so we'll write it as A inverse exists. If and only if, so this double arrow just means this is equivalent to saying the determinant of A is not 0. Okay, so that's something in the chapter summary. I recommend that you know everything of this. I don't ask this kind of question every year, but I did in this last year. You should know that could well come up on your assessment. Okay, it's the only kind of theory that if you understand what we're saying about determinants being scale factors, if you go back to that section and look at it, it's kind of, you can kind of work it out like that. I'm not a big fan of learning things off. If you think about it, so if the scale factor is not 0, that means that kind of say 2-dimensional, in this case 3-dimensional solids are sent to 3-dimensional solids, and then there's enough of them that you can send back, so it's invertible. And then if the determinant is 0, that means you get a 3-dimensional shape going to either 2, 1 or 0-dimensional shape, and there's not enough points to send back, it's not invertible. But however way you want to think about it. To calculate the determinant, we do this right down diagonals minus left down diagonals business as so. So you write the matrix again. I'll probably just go over here, careful not tripping the wires. I'm just going to check this. Of course, you can make a little slip. We all can, writing down the question. Right, that looks good. So we're going to do, how do we do this? You write the first, now this K is nothing to do with K hat and vectors. This is some constant. Now it seems a little unlikely, like it's kind of weird. Every value of K, what does it say? Yeah, this thing is invertible. So somehow this is going to have to come out never to be 0, which seems bizarre because there's infinitely many values of K. Surely some of them make this 0. But anyway, we'll see what happens. So this thing, if you remember, is right down diagonals, like kind of like dot products, K by 1, 4 by 1 by 3, minus 1 by 1 by 1. What's that? K by K gives K squared. By 1 is K squared still. 4 by 1 by 3 is 12. Minus 1 by 1 by 1 gives us minus 1. Okay. Take away the left down diagonals, which is 4 by 1 by 1, K by 1 by 1, minus 1 by K by 3. 4 by 1 by 1 is 4, K by 1 by 1 is K. And then this is minus 3K. This question is tricky enough. Okay. Am I missing a K somewhere now? No. Right, so what we get is, if we tidy this up, we get a K squared. You get, now this is minus 2K, but it's minus 2K, so it's plus 2K. And this is 11 minus 4, which is 7. And there's various different ways of going from here. So to show that this thing is invertible, we have to show that this is never equal to 0. Now there's various different ways about this, and I could spend quite a lot of time, but I think if you get down to here, I think anybody who kind of does something like, this was worth 4 marks, anybody who did question mark, is this equal to 0, is getting 3 out of 4. You'd have to know a little bit more to solve it. Now you can think about it, how would you do it? I'll mention a few different ways of doing it. One is that probably the easiest way is, I think the easiest way is try and solve it equal to 0 and see what happens. So we'll try and solve it equal to 0. You can try and factor it, and you'll see that it has no nice factors. Because, so 1 by 7 is 7, the factors of 7 are 1 and 7, they can't make up 2. So we should use the minus b formula. So k is minus b, which is minus 2, plus or minus square root of b squared, which is 2 squared is 4, minus 4 by 1 by 7, which is 4 by 7 is minus 28. And now we can see the problem over 2 by 1 is 2. Here is your problem. Square root of a negative number. There is no number that squares to give you minus 24. So there's no real number, k, that makes this equal to 0. So what I would write here, if you get this, you're getting full marks, but to do it, no real roots. And that means that the determinant of a, which is this, is not equal to 0, and that implies that A is invertible. A inverse exists for all k. A tricky question, no doubt about it. This is the important bit though. You get most of the marks if you get to here. As I said, you get 3 out of 4 if you get to here. And then just something to finish off. You probably don't need all of this, but there you go. Okay. One more question. Now, in terms of tips, I don't really give them, but if you look at past exam papers, you'll see there's usually a 3 by 3 Cramer's rule, and that's the usual. This was an unusual paper last year in that it had 4 parts, but usually there's a 3 by 3 Cramer's rule, and I recommend that you prepare that. That's not a hint for the tests, genuinely. I don't even know, I haven't looked at it, but most years there's a 3 by 3, so you should be prepared for that. This one, however, has a 2 by 2 Cramer's rule. Okay, so we're given a linear system. Now I'm just going to go right ahead and write it as a matrix equation here. So this is 0.41 minus 0.67, 0.012, 1.3. So Cramer's rule, we say, is actually kind of crap. It's okay for 3 by 3s if you want to find one of the variables. Where its real beauty lies is if you want to solve a 2 by 2 system where the numbers are decimals. In my opinion, that is what it is good for. And you do get 2 by 2 linear systems with decimals. So it certainly makes sense to do this. Okay. So it says use Cramer's rule or another matrix method. Now if you want, you can go off and use the inverse matrix method again, but I don't recommend it. I recommend Cramer's rule to find x, correct the 3 significant figures. So our Cramer's rule says that x is equal to dx over d. What d is the determinant of this matrix. And what dx is, it's the same thing, and this holds of course for the 3 by 3, except instead of the x coefficients here, now if you look back at the question, you'll see that these are the multiples of x, the coefficients of x, put in the constants. And then you're left with minus 0.67, 1.3, and now it's just a question of right down diagonal minus left down diagonal. Now, it's asking for a 3 significant figure rounding. My recommendation is you shouldn't round until the very end. So we'll do full precision on this. Now I'm going to be a bit lazy actually, because what I'm going to do is I'm going to put that by that minus that by that in the calculator at one go. It's not illegal. Now careful with the sign, it's minus, 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 3 minuses is minus, because 2 of them makes plus and another one makes it minus. 0.67 by 0.33. And I'm going to take the full precision here, minus 0.0651. Actually, I didn't know rounding here. But the thing is, like, if you want your final answer rounded to 3 significant figures, previous rounding, like even to like 5 significant figures, could mess up even the 3 significant figure calculation, as you see in the error analysis. Well, as you might think about in the error analysis section. Next one is 0.41 by 1.3 minus, well, it's minus minus, I'm going to make it plus, 0.67 by 0.012. Surely we'll get more significant figures here in this one, yeah. So there's no rounding here, 54104. Now we will round to 3 significant figures. So I get minus 0.0651 divided by 0.54104. 3 significant figures, out it comes minus 0. Now significant figures is not the same as decimal places, in this case it is, so that it's 0 and the first non-zero number is the first significant figure. It just happens to be the first decimal place here, and then you do 2 more to make up 3, rounding if necessary. Now it's 0, 3, which doesn't round. There we go. In terms of what we said, and we can talk about it actually for part C. Did we answer the question I was asked? Did we show carefully that A is invertible? Yes, we did. Does our answer make sense? I suppose it does. Well, it does, because we were asked to show that it is invertible. If it was investigated, it might be a bit trickier that. This one, have we answered the question that's asked? Use Cramer's rule. We did that. To find x, we did that. Correct the 3 significant figures, we did that. We did all the things we were instructed. Does the answer make sense? Sure. If you have time, in this assessment you probably have time, because I'm giving you an hour to do the question, and it's kind of half an hour for the question, 15 minutes extra time, and then 15 minutes to upload. So you should be able to here actually solve for y as well, and then check your answers. Why not? To make sure you're right. Okay, so that's that.